Graphing growth. We're going to be looking at how to graph an exponential growth function given certain transformations. The truth is, graphing exponential decay is basically the same thing, but I'm going to be doing that in a separate video. Okay, the main transformations that we're going to be looking at in this video are going to include an A, an H, and a K. The A value is going to be a vertical stretch or compression. Okay, either stretches the graph up or compresses it down. The way that we're going to approach that is to relate any point to that horizontal asymptote that we have. The H value, that is going to be a horizontal shift, okay, or horizontal translation. Remember, because this says x minus h, that means that whatever you see the h as, you're going to move in the opposite direction. So if it said x plus 5, you're actually going to go to the left, the negative direction, 5 units. If it says something like x minus 2, you're actually going to move 2 units to the right. You're going to move in the positive direction. The k value is going to be the vertical translation. That's a shift up and down, and you do that as it appears. If it says plus 3, then you're going to move up 3. If it says minus 3, you're going to move down 3. In addition to these 3 things, there are other ways to transform the graph. You can vertically flip it, you can horizontally flip it, you can even stretch or compress horizontally. But this will be the focus for today. All right, so let's take a look at this function. The way that I'm going to approach graphing these is to really think about the parent function that would correspond to this. Okay, every exponential function has a different parent function, which would be based off of the base value. In this case, the parent function would be f of x is equal to 2 to the x power. That would be the parent function. Okay, what we're doing to this graph is a horizontal shift and a vertical translation. Those are the 2 things that we're doing. We don't actually have an a value. We don't have anything out front, so we're not going to vertically compress or stretch. All right, so the way that I'm going to approach this, I'm going to think about the parent function, which would have an asymptote at the x-axis. The graph would start here and then increase this direction. It would pass through the point 0, 1. It would also pass through the point 1, 2. Okay, so there's a couple key points that I have from here. Okay, the way that I'm going to tackle this, what I'm going to do is use my translations to reset the graph, almost pretend that the origin is located somewhere different, then plot those points that I just described. Okay, the minus 5 is going to shift the whole graph down 5 units. In other words, the horizontal asymptote is going to shift down 5 units. Okay, so I can go to negative 5, and I can draw the horizontal asymptote. The x minus 4 is going to shift the graph 4 units to the right. It's going to move in the positive direction. Okay, so I'm going to draw a vertical line here. It is not an asymptote, but what it's going to represent is the y-axis in a different position. Okay, so again, that is not a vertical asymptote, but this is going to be a horizontal asymptote. Okay, so pretending that this is the origin, for this parent function, I can plot a point here because 2 to the 0 power would be 1. So I'm thinking that this is the coordinate 0, 1, even though it's actually over here. But the shifting is going to move it all the way to this position. Okay, and then after that, I would think about if I plugged in a 1, I would get 2. So I'd go over 1 and up 2. Okay, and I can continue to plot some points based off of the parent function. I could go out 2, which would be 2 squared. That takes us to 4. Okay, so I count up 4 and I get a point there. In the other direction, 2 to the negative 1 is going to give you 1/2. 2 to the negative 2 is going to give you 1/4. All right, and then from this point, I can basically just connect the dots. Okay, asymptotes are difficult to draw. Okay, that should be pretty good. Okay, and then what we can do, just for the sake of doing it, is we can test one of the coordinates to see if this actually worked. Okay, let's take this coordinate here, which would be at 6, negative 1, and just test it into this function. Okay, so we're hoping that negative 1 is going to be equal to 2 to the x minus 4 power minus 5. Okay, so x minus 4 is going to give us 2, so we got 2 squared minus 5. 2 squared is 4, minus 5 is in fact negative 1. It checks out. All right, so the domain and the range. The domain actually doesn't change with respect to the parent function that we would have here. It is still going to be all real numbers. The range, however, because of that vertical translation down 5 units, is going to change. We're going to have an open interval from -5 to infinity. Example 2. What I'm going to do is begin with the translations, just like I did in example 1. Okay, now in this case, I've only got one translation, which is that -2. Okay, so my horizontal asymptote is going to shift down to -2. We don't actually have a horizontal translation. Okay, so I'm going to go ahead and highlight the y-axis just to do it. And as I continue through the problem, I'm going to pretend that this would be an origin. Okay, and I'm going to think about this function. Not exactly the parent function, because I'm going to keep that 1/2, but I'm going to think about that function. Okay, that -2 has already been dealt with. Okay, so if I were to plug in values and plug in maybe a 0, this would become 1. And normally, we'd get a point right here. But that 1/2 is going to compress everything towards that horizontal asymptote. Okay, so instead of being at 1, we're actually going to end up at 1/2. Okay, my next coordinate would be when x is 1, which would typically give you a 4, but we're going to take half of that, so we're going to get 2. So if I go over 1, then I go up 2. After that, 4 to the second power would give me 16, but half of that is 8. Okay, so from here, let's see, that was at 2. You've got 2, 4, 6, 8. Okay, and on the other end, it's going to compress pretty fast over here. Okay, at -1, you're going to get 1/4, but half of a 4th is going to be an 1/8. Okay, so you're going to be really close at that point, so you're basically at the asymptote. And this is your graph. The domain is going to be all real numbers. The range is going to be -2 to infinity. For example 3, we went ahead and threw in a negative here. What that is going to do is vertically flip the whole graph. However, the way that I'm going to begin this is with the translations, just as I did in the other ones. So the +3 is going to shift that horizontal asymptote up 3 units. It's going to be over here at 3. The +4 is going to shift everything to the left 4. Okay, so I'm going to put a vertical line at -4. And I'm going to pretend that this is the origin as I think about this function. Okay, so the +4 and the +3, those have been dealt with by moving all of this around to that point. And I can focus my attention here. All right, so if I was to raise 3 to the 0 power, I would get 1. But that negative is going to cause it to be a -1. So instead of starting from here and going up 1, actually going to need to go down 1. Get a point there. The whole graph is going to get flipped vertically. With a value of 1, I would get 3, but it will be a -3. So I'd go over 1 and down 3. If I added 2, this would be 9, but a -9. So go over 2 and then down 9, which will place you right there. Okay, and on the other end, it's going to be pretty tight again. If we use a -1, we get 1/3, but it'll be a -1/3. Okay, so we're about there. Our graph will look like this. The domain is still all real numbers. The range, we've now flipped it. Okay, it's going to be bounded above, so we're going to come from -infinity up to 3.
Wait, what?